This was back on page, let me just make sure. And I can't do it all. I wish I could, but I can't. Okay, so in the 50s, somewhere in the 50s, I think we did the check if data is normally distributed. No, gotta go back a few pages. Yeah, so page 44. So check if data is normally distributed. Okay? Check if data is normally distributed. I would say determine mean and standard deviation. Arrange data. Create frequency line and make bins. Place data in bins. Example. Okay. So you should be able to, if, let's just use an easy number. If your average is 80 and your standard deviation, can we write this down at the top here? Let's say your mean is 80 and your standard deviation is 5. Let's keep it simple here. That would make this 80, 85, 90, 95. Okay. Then this would be 75, 70, 65. I will zoom into that corner there. And I'm just going to put some values in here. 5, 5, 6, 7. 1, 2, 3, 4. 1, 2. Maybe you have one outside there. Let's just do the math here. This is 5, 10, 17, 21, 24. Highlight that 24. Okay, once you figure out how many values are we considering, 1,500, I will not give you more than 50. Not more than 50, I promise I'll keep it less than 50. 50 or less, I should say. 24, let's say it's 24. Then you check. Check. Plus or minus 1 standard deviation. You want to compare it to 24. Okay, and then you multiply it by 100. Plus or minus 2 standard deviations. You want to compare the number of values that exist within the plus or minus 2 standard deviations. Multiply by 100. And then plus or minus 3 standard deviations. It's out of 24. I have to warn you, it's not going to be 24 every time. That number varies, but it has to do with my total based on my frequency table, frequency line. What are we comparing the first to? What's one of the magic numbers here? 68. The second one is 95. The last one is 99.7. plus or minus 5% is acceptable. Make sure you put this down. Okay, so what I mean by that is if it's above 5% or less than 5% when you compare, it's still acceptable for us. So if you do this math, so for example, plus or minus 1 standard deviation, we'd be looking at how many values are here? 5, 10, 12. This will be 12, right? If you add everything up here. Oh, that's easy. What's 12 divided by 24 times 100? It's half, right? 50%? Would this pass? No, it fails. It's way, like 63 would still be acceptable, but anything less than 63 is not acceptable because, right, if you go 5 less than this, that's 63. So this one fails. You may stop. You don't have to go through the other, but keep checking. If it passes here, you keep checking, okay, until it fails. I'll tell you this. If it fails in the first 2. The last one is almost always a pass, right? You're probably going to get 100% on the last one, which is very close to 99.7. So this is something that I would expect you to know how to do. There's one on the quiz. I'm going to give you, if you need more practice, another AC to take home. So that's that, okay? Make sure you have that on your study sheet. And then I want to just add the 2 formulas that I gave you today. Finding the mean and the standard deviation without the TI-84. And I know I'm going a little fast, but I'm determine mean and standard deviation when upper and lower values and z-scores given. I don't know. This is probably not the best title I can think of, but I'm trying to not make it too short that you don't know what you're doing. Okay, so determine the mean and the standard deviation when upper and lower values and their z-scores are given. Okay, so you want to first do this, upper, lower, z up, minus z low. You start with that. To find the mean, we go x plus standard deviation times z. And I'm going to use a red pen for this part where I make an arrow go to that one. I'm closing that off there. Last but not least, when different data is compared, calculate z-scores to level to standardize. Okay.